I wanted to create this video to help others as I walk through troubleshooting my own pressure regulating valve to see if it's still working properly or if it's failed. My reason was driven by noticing that my water heater was dripping via its pressure relief valve, which is typically factory set to 150 psi, telling me that the pressure inside my plumbing system was too high. As a reference point, plumbing codes refer to 80 psi as a maximum allowable pressure that should be inside of a plumbing system. Before we get started, there are two things that are helpful to know and ensure before starting this process. From a terminology standpoint, total pressure is made up of two components, your static pressure and a dynamic pressure. Bernoulli's equation states that total pressure equals static pressure plus dynamic pressure. I won't go any further with that because it's too complicated for this video, but I will be using this terminology throughout the video, and we'll also see the impact of each one of these components on the pressure gauge as I walk through this process. Secondly, you want to ensure that your water heater is not going through a heating cycle, as it will introduce additional fluctuations that will not be desirable during this process. So first, as we get into the diagnosis of this, the first step is to obtain and install a pressure gauge, as you see here, so we can observe the different pressure fluctuations inside of our plumbing system. So let's go ahead and get started and turn on this plumbing system and see what the total pressure inside the system is. So you can see the pressure pops straight up to 100 psi, which is obviously higher than the pressure that we recommend for maximum pressure of 80 psi. So the next step is to open up a fixture inside your house and let the water start flowing, and we can see what happens. And as you can see, what's essentially happened is you open up a valve and you relieve the static pressure within inside your system. So this is a reading of the dynamic pressure that's inside your plumbing system. And this is the first indication that something's going on with your PRV. It's not operating like it's supposed to. As the total pressure was 100, and when you open the valve, it dropped down to 50. I mean, you should never have that type of fluctuation inside your plumbing system. So that's the first indication that something's gone wrong. So the next step is actually to verify this is to close your valve inside your house, and let's watch what the gauge does. So obviously the pressure is increasing inside your system, and this is the second indication and confirmation that your pressure regulating valve is something's failing inside there. Is what happens is in a pressure regulating valve is you have a diaphragm, and the incoming pressure after you turn off your valve, the incoming pressure should build up enough pressure on the inlet to overcome the pressure of a spring that you can set manually, and it should close the valve, eliminating any future flow into your system, which eliminates any additional pressure that's allowed to enter your system as well. So, armed with all this information, you can tell now that your pressure regulating valve is bad. And coupled with the fact that I know my pressure regulating valve has been in service for 25 years and hasn't been touched, the typical lifespan of a pressure regulating valve is around 10 to 20 years, depending on a lot of variables about the quality of water and the abrasiveness of the water flowing inside this pressure regulating valve. I know it's not working as it should, and something needs to be done if you want to reduce the pressure inside your system. So there's three options. Obviously, you can do nothing, you can actually rebuild your valve, or you can completely replace your valve. So at this point, I'm going to conclude this video, and I hope this helps as other people are troubleshooting their plumbing system. Thanks.